Hi guys, today we're looking over polymers and giant covalent structures. In the next video, we will go over exam technique and difficult questions related to the topic which has come up or may come up in the future papers. A polymer is a repeating unit of a small molecule. In this case, it is ethene. Many ethene molecules build up the polymer called polyethene. The N shown here simply shows us that there are many ethene molecules. You can think of it from mathematics as nth term of a repeating sequence. Polymers have strong intermolecular bonds between the atoms. This means they need lots of energy to break, which gives them a high melting and boiling point. This is also why they are solid at room temperature. Room temperature isn't high enough to melt the polymer. In terms of other compounds, this is where polymers sit. Simple covalent molecules have the lowest melting and boiling point, and diamond has the highest. You can remember this by thinking logically. Oxygen is already a gas at room temperature, so it must be the lowest. Rubber gloves are reasonably easy to melt. Salt is harder to melt, and diamond obviously has the highest melting and boiling point. You will also need to know allotropes of carbon. These are simply different forms of carbon. Diamond and graphite are both made up of carbon. Looking closely at diamond, each carbon atom makes 4 strong covalent bonds. This makes diamond hard and it leaves no delocalized electrons that are free to move. This means diamond can't conduct electricity. Diamond also has a tetrahedral arrangement. That's where whichever way the structure sits, it will look the same. You can think of it from a tetrahedron, which always has a corner facing upward. We already know diamond has a high melting and boiling point. However, we can also say that diamond is a rare form of carbon and is quite shiny as well. Some common uses of diamond can be for jewelry and some cutting tools. Comparing this to graphite, we can see that each carbon atom only makes 3 covalent bonds. This leaves a delocalized electron that is free to move around the structure. Therefore, graphite can conduct electricity. Graphite is also made up of only carbon atoms, but it has a hexagonal arrangement. Between the layers, there are weak bonds, as shown by the dotted lines. This means the layers can slide on top of each other. Therefore, graphite is quite brittle and easy to snap. Each layer on its own, however, is quite strong. A single layer of graphite is called graphene. The uses for graphite can be for pencils, lubricants, electrodes for electrolysis, and conductors. You may have to compare this to silicon dioxide, which is just sand. Silicon dioxide isn't an allotrope of carbon, because if it was, it would only contain carbon. Like diamond, however, the structure also has a tetrahedral arrangement, and the structure is made up of atoms as well. We can notice that every oxygen atom makes 2 bonds with adjacent silicon atoms. Like the other examples, the bonds are also covalent. Finally, you will need to know about fullerenes. These are just another allotrope of carbon, but they form a sphere and even a tube shape. Fullerenes often make hexagon shapes which curl around each other. Fullerenes can be used to trap other molecules within them for drug delivery. Their large surface area allow them to be great industrial catalysts. Fullerenes can also be used as lubricants. The carbon nanotubes on the right have a high length to diameter ratio and a high tensile strength. They also are lightweight, which make them great for the use of making things stronger without adding too much weight. Badminton rackets, for example, can be made stronger without sacrificing and adding on too much weight. Well, that's the end of this video. We will go over multiple exam questions tomorrow, which will be very useful for your revision. See you then.